Oh. Hmm. Since I'm not going to collect this particular quiz, feel free to discuss with your neighbor when you get to the point where you're either all done or don't know what the next step is. So we'll go over this together, though, in about 2 minutes. Well, I don't know if you're whispering about the quiz or if you're whispering about the adventures you're going to have in the next week. So let's go ahead and do this one together. As always, when on Friday when we do have our exam, you're not going to be able to use your cell phone calculators. So I have my stack of calculators over there. First come, first serve though. So bring your own because I don't have a lot of them. I think I've got a dozen or so. Uh, so they're mainly there for emergencies if your calculator stops working or what have you. Also on the exam, I left off the little lines on these curves. So I just checked the exam. I do have the lines. On these Gaussian distributions, the normal distributions. So just as a guide, you don't really need them, but let's go ahead and do this one. So it says that apartments are normally distributed with a mean of the size is a mean of 1,000 square feet, standard deviation of 300 square feet. And so if I were to mark this off, I might do something like this. This would be 700 and so on. So each one of these curves you would want to label. And the most important label that you're going to put on these curves is that mean. So if you want to be lazy and you don't, if you're really, I don't know, if you don't want to write everything down, you could always just put 1,000 in the middle of each one of those. Because even if we're applying the central limit theorem as we are with letter B, we're still going to have a mean of 1,000. So that's the beginning. Now it says, what is the probability that the area of a randomly selected apartment is between 800 and 1,000 or 1,100? So let's go ahead and put those on here. Here's 800, and here's 1,100, 1,100. Whoops, whatever. And so that's what I'm looking for. So on the exam, it still is a mystery to me why some students just leave these blank. Literally, I get some exam answers. They've got an answer over here, but these are blank. So when you get to the exam, put something there. You give me something, okay, so that I can give you some points for that. So think through where do the lines go and so forth. In the shading, that gives you a guidance as to what you think the answer is probably going to be about 30% based on what's shaded there. Now let's go down and figure out what we're going to do. If we had Excel, which we're not going to on this exam, you're not going to use Excel, but I have all of the stuff you need down at the bottom. What we would do is we would do norm. You don't have to memorize this because, like I said, it's all down at the bottom. But I just want to point out that I'll do this, okay, whatever, minus the norm dot dist of this stuff. So let's go find those two numbers down at the bottom. So I have them here. Let's see. Here is 1,100, and this is 800. Be careful because I want to be able to let you use the central limit theorem. You'll notice that there are two 800s. There's this one and this one. That one is the one that we would use for the central limit theorem. This is the one we're going to use for single. The big difference is that this one has standard deviation of 60, which is the adjustment that we make for the central limit theorem. So anyway, back up here. There's our, I have to get these numbers, which I don't think I can memorize all 8 of those digits. So let's go ahead and jot them down. So I've got 0.6305 minus 0.2524. So whatever that is, let's see, 0.33, 3 minus 5 is 8.7, 8.2.1. Did I do my arithmetic correctly? Okay, good. Thank you. You guys are very sedate today. So, but anyway, there's the, so there's that one. Let's do the rest of these a little bit quicker. Maybe I'll get a calculator so I don't have to do this in my head. Once again, a bunch of calculators in that drawer. I'll have them set out. I'll give you more instructions about the exam at the end of class. So before you leave, don't wander off before I tell you a few other things. about the test. Okay, so for this one, same deal. If I actually were to, but you'll notice that we're averaging together 25 apartments, and so the new standard deviation will be the old standard deviation divided by the square root of 25. You can do this on your calculators if you need to, but it's 60, pretty straightforward. Square root of 25 is 5. So that just means that everything is a little bit more compact. And so 800 is going to be much further away from the middle than it is in the previous problem. Whoops, 1100. There we go. So that's the area. This is going to be much bigger, a much larger percentage. So let me go dig out of my table here, the numbers that I need. So now I'm working on these numbers. So those are the two. So here, I'll just write this down, 0.9522 minus 0.0004. So 0.9518, I guess. That one was easy. I could do it in my head. So any complaints or questions? So this is kind of like the minimum. If you're wondering, what am I looking for this curve, the normal curve? You just have to put the middle, so the center, and then do your best to put the numbers that you're interested in on there. If you want to put the standard deviation, great, but it's not, I mean, this is kind of like if you're really lazy, just do it this way. You got it. But don't do this. Don't leave it blank. There. Don't do the bottom one. Top one. Okay, next one. We'll do this a little quicker. It says 25 apartments, so we're using the central limit theorem again, so we'll use 60 for this, for the standard deviation. We want to know probability of being more than 900. So there you go. So this, because Excel is leftist, you're going to have to take the answer that we get from the table and subtract it from 1. So this isn't too bad. 1 minus this number, 0.3694. Oh, no, wrong one, right? Just a minute. That goes down there. Okay, try again. 1 minus this number. Sorry, I heard some groans. It's okay. You can yell out if you want. I have other classes that are happy to yell out, "You're wrong." Yeah, I know. Okay, so 0.9522. That look good? It's not bad. So there's that one. And then, of course, the last one, put your 900 here. I know it looks almost the same. In reality, this 900 on the bottom curve should be a little closer to the 1000. This one probably should be a little further from the center. But I'm pretty loose in terms of how I grade the curves. I'm just happy that you don't give me this over here. Okay, so once again, I've done most of the work. So this is 0.6306. How's that? So any questions, concerns, complaints now that I got all that out of my system? Yeah, what do you think, Elizabeth? It will be almost exactly. I'll show you the exam in just a minute. Nope. Yeah, you'll have those. Yeah. So, yeah, I haven't figured out how to use Excel during an exam. I know I have colleagues who are more brave than I am. Anyone else? Other questions? All right, well, let's take a look. Speaking of the exam, that's my main thing for today. I just noticed when I went to Moodle just a second ago that I hadn't enabled the answers, the alleged answers, as I like to say. I just have it. It's shown now, so they're alleged because I make mistakes, and if I do have a mistake on my answers, I'm happy to correct it. Just send me an email, and I'll probably put a note in here. However, this was available, test 2 practice questions, and you might have had a chance to take a look at them. And so that's what I wanted to take a look at. And as promised, I will show you the actual exam in just a minute. But first, let's take a look at the practice test. So this is a test that I gave a couple of years ago. You can see the types of questions that I like to ask. So most of this is pretty straightforward. I'm pretty sure that you're probably going to be okay with this. I'm curious, though, to find out where you're worried. But you'll see a lot of things that you're familiar with. And then here's this binomial distribution. That's where we've used Excel in the past. And so the Excel stuff is the binomial distribution and the normal distribution. I believe that's it. After the break, we're going to use Excel almost every day. Just to warn you, we're going to be doing confidence intervals. We're going to do hypothesis tests almost every day. And so just be aware, I guess, but on the exams, you'll see how we do this. That's what the quizzes are for. Wow, I have two binomial? Huh, I have two binomial problems on the practice test. Maybe I concatenated several exams, I don't know. So you have things like this, the mean median mode, which you should hopefully know how to do. Some questions about z-score, some skew. You've seen this sort of thing before. What is this? Oh, empirical rule. We went over that briefly. We could talk about that if we need to. You've seen this before. We had a quiz like that, so there's more practice for you. And then at the end, you have this stuff. So that's almost exactly what the exam looks like. Let me just show you the exam briefly so that you can see and be encouraged that it's basically the same. I tell students this, every time we have an exam, and it seems like some people don't believe me. If you take a look at the practice exam, you're going to do well on the actual exam. Take a look at your quizzes and your practice exam. That's where I get my material for this. But you can see, look, it's almost exactly the same as the practice test. See at the bottom here, all these normal curves, and you have this problem. You can almost see it if you squint. So anyway, let's go back to the practice test and see where it is. Some of you, if you followed my instructions on Monday, hopefully you had a chance to look this over. Was there anything that you are dying to know about, that you're worried about, or you're just curious about? See, I know that what you guys are doing is that you're hoping that if you don't ask questions, this is the way I am in faculty meetings, is whenever there's open for questions, I always think, please don't ask any questions because then we can get out of here early. But I think that it would be useful to take a look at a couple of things. So if you don't have any questions, I have some questions. And so I'd like to take a look at a couple of these just to make sure that you know what's going on. And these are the things that are the most popular questions to get wrong on the actual exam. So let's take a look at on this one. Let's see, is that a good one or is there a better one? Ooh, I like this one even better. Yeah, let's try this one. So this is number 12, but in particular, I'm interested in D, E, and F, those three. So those three, I don't know if we did outliers and interquartile range. We can talk about that though. But let's take a look at this. Take a minute, work with your friend or your neighbor. See how you do. If you haven't tried these already, try this here. So I'll give you a couple minutes and then we'll pick some volunteers to help me out. There's so much whispering, but I don't know if what you're whispering about. So you can talk if you want to, but I know it's early and you feel like you keep it down. You don't want to wake the baby either. Yes, although it's a different building, I think. Let's take a look at this and see how you're doing. For letter D, we're computing the 67th percentile, so we need to know where this is. That's why I put location there. Where is it? Where am I going to go to find this 67th percentile? Kirsten, do you know where you're going to go? Like, do you know the formula for the location? Like, yeah, it's the letter D there, the 67th percentile. Do you remember that formula? You're skipping up to the quartiles. All right, we can save the. Then I'll save you for the quartiles. How about you can tell me how to find quartiles? So did anyone do the percentile or know where to find the percentile? You got it. All right, Anna. Oh, uh, so but the okay, you're skipping ahead. I think you're right. I don't know. You have to look up my answer from when I wrote it. I was thinking of the location, like where is it? Like what house number? Like how did you find that it was 15? Okay, you took a guess. All right. So, but there's a location. There's. Oh, you want to come back to Kirsten? Okay, Kirsten. Yeah, pretty much. Pretty much. 67% of 40. Jesus, did you want to add something to that 40? Okay, I was hoping that you would want to add just a little bit to the 40. Does anyone want to add something to the 40? Yeah. Add one to the 40. So it's 67%. Well, the way that at least our book does it, and I've noticed as I've taught this for I guess 28 years, is that different books present this in a slightly different way. So this is our book. So 67% of n plus 1. So add 1 and then do 67% of that. So you probably are going to get about the same thing if you do it with 40 because it's such a big number. Yeah, what do you think, Elizabeth? Okay. Okay, so let's, okay, do I really need to do this? Okay, okay, why do we do one? So, so let's think about, let's do the midpoint, the median, sorry, the median. So think about where the median is. The median of a set of data is right in the middle. But if you were to take, like, let's say there were 40 numbers, the median is not the 20th number. So you add one to bump it up a bit so that you get the middle. So if you want the middle of 40 numbers, you're going to find it between the 20th and the 21st. So that's an explanation, I guess, for the middle. But all the other percentiles, it's sort of similar, is that in, there are, so there's 40 numbers. Yeah. You're hitting me up here early in the morning. I'm going to claim the early morning thing again. But that's I mean, if you think of the middle again, then, you're going to have to shift everything just a little bit to make sure that you're at the right place. Yeah, sorry, that's not a very satisfying answer. So, but anyway, so yeah, it's always going to be one more. By the way, the other way that I've seen this done in other books is you do it exactly the way you've been doing. You did it just now. Take 40 and divide it by 2 or whatever it is. And then if you get an integer, then you have to sort of bump it up a bit. So there's different ways to deal with the fact that you're not going to get at the exact location. Anyway, 41. So we'll do 67% of 41. So Jesus, you did this on your calculator, you said? Yeah, what did you get? 27.47. Okay, good enough. So 27.47, which is going to be the 27th and the 28th numbers. We're going to average them together. So now we just have to start counting. Remember, this is a frequency. So we have 1, 2, 3, 4 numbers here. 1, 2, 3, 4, 5. So we're up to 9 numbers. Here's 10. So there's 20 numbers. How many do I need again? 27.5. Ooh, wow. Oh, Anna, you weren't right. Okay, you're almost right. It was close. So 21, 22, 23, 24, 25, 26, 27. The 27th number is a 15. The 28th number is a 16. So 15, you're going to average those together and you get 15.5. Very nice. All right, well, this is good. So it's good that at least I remember what students got wrong in the past, because now none of you are going to get this wrong on the test, right? Okay, please no. So this will make me happy. By the way, I just got to say, last time you guys did such a good job. Like I was serious about how my wife always doesn't like it when I'm grading statistics exams, and she was really happy the morning, like when I was grading them. There was no anger or rage. It's like I just am like, why? Why do you get this wrong? So do it again. Do it again. I'm rooting for you. Okay, let's do these quartiles. So I know Kirsten knows how to do it, but I want to see who else does. Biella, do you know how to find quartiles from a set of data? Like, what are you going to do? Okay. So you're going to do the same thing we did with the percentiles. Very nice. That's one way to do it. Just so you know, that's not the only way. So I like Biella's method. Let's go ahead and do this. So it's going to be, we'll talk about the other way as well. I'm curious to see if anyone did it the other way. So we're going to do 25% of 41 again. And this is going to be what, 10 point something or other, 10.25. And so we're going to look between the 10th and the 11th data. Datums, however you want to say it. So between 10 and 11, so we're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th number is a 13. The 11th number is a 14. So quartile 1 is going to be 13 plus 14 over 2, 13.5. All right, so there's quartile 1. I'm guessing you're going to do the same thing for quartile 3. What do you think, Oz? Yeah.
This may sound dumb.
No.
Why don't we? I'm glad it's simple. Do you not have to like multiply like the fourth of the 10th to the 13th?
Yeah, no. It's not dumb at all. Actually, if I think maybe Excel is like this. That's the way that if you have a computer doing it, that's the way the computer will do it. So what you're suggesting is, yeah, you would say, yeah, since it's 0.25, you're right, go a fourth of the way instead of half the way. So no, that's brilliant. I love it. But I don't. Yeah, it is way more. It's exactly what you suggest. It's more complicated. So let's not. But I think let me check. Oh, I'd have to actually reconstruct this data set in Excel. Wait, no, we can test this. I think. Let's just a sec. Here, let's do this real quick. This will be fun. Let's see. I won't reconstruct the data set. I'll just pick 4 numbers. 1, 2, 3, 4. Okay, so if we were to do this, the median second quartile median is going to be between 2 and 3, which is 2.5. The first quartile between 1 and 2, 1.5 is what we'd get. Let's see what Excel gets. So, oh, and there's this difference between excluding and including the endpoints. Just a minute. Yeah, it just gets more and more complicated. But here, let's see, equals quartile. Core dot inc. I think the inclusive one. Guess we're going to find out. Let's see what happens. And I want the first quartile, which is the 25th percentile. Yeah. Oh, yes. Oh, wait, 1.75. Let's see, 5 divided by, just a sec. No, sorry, this is getting down a rabbit hole. You can blame Oz for this. 1.25. Yeah, I would expect it to. Let me see. What if I did the exclusive? Just a minute. So exclusive exc. Oh, there it is. Okay, so there, this is Oz's. There's Oz's version, and then yeah. So Excel, if you have a computer, it's easier to do that sort of scaling in between. But we're not going to, and we didn't when we did this with what it was Newton. No, I love it. Thank you, Oz. That brings me hope for this new generation that you actually are thinking about the consequences of what we're doing. Very nice. Okay, let's do that's the first quartile. There, I blabbed enough. Let's do the median. The median is going to be the middle number, and so there, just like with this, we're going to just do 50% of 41, so that's 20.5. So we need the 20 and a half number. I believe it's between these two. If you count, you get 14 for 20, the 20th number, and 15 is the 21st number. And so the median will be 14.5. And then the quartile 3 is going to be the 30.75, I think. So 30.75, but we're just going to do the between the 30th and the 31st. But fortunately for us, the 30th and the 31st numbers are both 16s. If you don't believe me, you can count. I guess we got up to what, 27 here, 28, 29, 30, 31. Both of them are going to be 16s. And so there's 16 plus 16 over 2, which is 16. Very nice. So there it is. This is another one. So like I said, popular wrong answer is the percentile and the quartiles. Popular, get those wrong. I think maybe because of this, I'm glad that we brought up this number that we're doing 41, not 40 when we're computing this. So take the number of data plus 1, and then you multiply. And I apologize for the poor answer as to why you add 1. It'll probably come to me, a brilliant answer right after we finish. But now let's do this box plot here again. I'm just picking the ones that people love to get wrong on the test. And so if you guys get this right, probably I'll have a lot of A's, maybe a lot of hundreds as well. Okay, so the box plot, what we're always going to do is we're going to have numbers. It's a number line. So starting at 0, and here's 10, and here's 20. I guess we just need to make sure we have all of the data because it goes up to 20. So maybe I was a little bit generous, well, not generous, stingy with my numbers, but there we go. And then we're going to make a box around the quartiles, 13 and a half to 16. Do your best. And then a line at the median. There it is. And if you really are bothered by the fact that I don't have, you could make your number line a little bit longer than mine. I just made mine a little bit too compact. And then you have a whisker that goes out to each of the biggest and the smallest. Ah, yes, I see. I didn't need all of this stuff down here. So there it is. There's my poor box plot there. Let me peek at this test really quick. Bring it back so that I know how to guide you. Excuse me. So there it is. Now I've got it zoomed in. I can actually read it. Let me just remind you, I don't know, did we go over interquartile range? I feel like we did, or maybe we didn't. We should have if we didn't. Interquartile range is just the difference between the quartiles. There it is. So this is 2.5. It gives you a sense of how spread out the data is. It's kind of like the larger that number is, the more spread out the middle, the big chunk in the middle is. And then outliers, I don't have this question on the test. Let me double check. Yeah, the outliers. So I know some of you are just going to shut down right now, but outliers, it's important to be able to identify outliers. So let me just, if we didn't go over this, I feel like we did, but I'll just remind you now, is you do this. You take 1.5 times the interquartile range. So let me do this on my calculator. Give me a sec. 1.5. I got 3.75. And that tells you how far away from the box you're allowed to be and not be an outlier. So that 3.75 tells you how far you're allowed to be away from the box. So let's see how far our numbers are. 16 is the top of the box. So if you're beyond this from 16, so here's 16, 16 plus 3.75 is 19.75. So 20 would be considered an outlier, this number, which kind of makes sense. If you look at it, that's kind of far away from the rest of the data. What about the other end? The other end of the spectrum, if you take 13.5 and subtract 3.75, you get 9.75, and that's below all of our data. And so there are no outliers on the bottom, but this is an outlier on the top. So outliers are just numbers that don't fit the general trend or pattern of the data. And we would ask the question, why? Why is there one person who is 20? Is this a 20-year-old? What is the data supposed to ages? So what is this 20-year-old doing riding the bus? Good question. I don't know. So maybe it's an error. So that's why we care about outliers. We might have made a mistake when recording the data. And so you want to track that down and figure it out. Okay, the rest of this problem is pretty straightforward. Let me just glance through and make sure that there's no other ones that are, oh yeah, this one. So we talked about the empirical rule briefly. Let's just talk about it once more. See how you do with this. Here, I will sketch this just so that you remember. We have 70 is the standardized test average, and the standard deviation is 3. And so this is what we're looking at in terms of the scale there. So there it is. So I want you to use the empirical rule to come up with a probability or the percentage, if you don't like the word probability, of people that are in these different ranges. So take a minute, see if you remember this. If you don't, it's fine. I'm going to go over it in about a minute, but you might ask your friend and see if they remember. Maybe this has been completely washed from your memory. Well, let's see how we do. All right, well, let's see. I know you're now actually talking, but let's go ahead and see if we, if anyone remembers these ranges. So there's the first one, between 67 and 73. Does anyone remember what percentage is between 67 and 73? Yeah, what do you think, Oz? Yeah, 68%. So there's these three numbers that you're going to remember, hopefully, but the middle block in a normal distribution, if you have approximately normal distribution, the middle, that first standard deviation is about approximately 68%. Approximately 68%. So 68% is the answer there. So what about the next one? Letter B asks for the probability of being greater than 76. To answer this, before I answer that, let's take a look at the percentage that is between 64. So 2 standard deviations. What percentage is between 2 standard deviations? Anyone remember that one? You got it? What is it, Caleb? What was that? 95. Thank you. My hearing is going, so I appreciate you enunciating. So 95%, very nice. So 95% goes between those. By the way, this is so important that actually is going to be sort of the basis for when we do confidence intervals in the future. We'll be able to say, hey, 95% of the time you're going to find the truth within 2 standard deviations of whatever sample you've taken. But anyway, that's getting a little ahead of myself. So 95% goes there, which means that I guess 5% goes outside that range. And when I say more than or greater than 76, what I'm talking about is this little sliver here. Well, if 5% belongs outside that range, we're going to have to split it up between the left and the right, the low numbers and the high numbers. We'll go with 2.5% for that one. Now, normally I like to have a different normal curve for each one of these, but on here it's just the one. Let's do the probability of getting someone less than 73 points. I think we have all the information we need on here. Just depends on how you chunk this up, but let's do this like this. 60 is there's 73. I'm going to put a line here. So here's my strategy. You might have a different strategy. It's fine. My strategy for doing letter C, since I want to know everything below 73, sorry, letter C, everything below here, I'm going to do this in 2 pieces. I'm first going to get this piece, which is pretty easy since you can see the answer almost right there. And then I will add that to this stuff over here. So let's do that piece that I've kind of shaded. Who wants to do that? I'll actually pick a real volunteer. This is the easy one, I hope. Yeah, what do you think, Carson? 34. How did you get 34? Oh, yeah, it's half of 68. Yeah, it's staring you in the face there. 34% goes there. Now, what about the people who are less than the middle? How many people or what percentage is going to be over here to the left? What do you think? Oh, someone said 50. You whispered it, but I heard you. Okay, 50%. So this is going to be 50% plus 34%, which is 84%. Very nice. So there's various ways to do this. Let's do the last one. By the way, if you did this a different way, nothing wrong with it. You can do this a lot of different ways. Like one way to do this is to take the middle 68% and then add on the stuff over here. It's a little bit harder, I think, but you do you. I don't care how you do it, as long as you get it done. Okay, next one, last one. So this one's kind of fun. It's like a little puzzle, isn't it? So, well, why don't I shade with my highlighter? Okay, so for this last one, I'll just use the green highlighter. It's everything between 64 and 73. Ooh, this doesn't look too bad either, does it? You know what I think my strategy would be is I think I will do this. The stuff that I've double highlighted, I'll do that. And then I'll do this. We've already done this. Carson gave this to us, 34%. What, is there something wrong? Yeah? Oh, you have the answer? Let's hear it. How did you get that? Oh, interesting. Yeah. Okay, so let's add that to 34. Just a sec. So we've got 34 is going to be the stuff on the right. And then we need to get this stuff here. Let's see. So yeah, I think that you're making it more complicated than it needs to be, starting with 50% and subtracting this. Maybe if we just take this 95% and split it in half, wouldn't that do it? We might get the same answer, but I think that that's going to be easier because 95 is the whole 2 standard deviations. This half will be half of 95, won't it? What's that? 47 and a half? Is that what you get on your calculators? So, whoops, why did I put 3? I don't know. 47.5, and whoops, I'm going to add this to this, and that's going to give me, what did you say? Was it 80.5%? Wait, 81, yes. 81.5%. Very good. All right, excellent. So yeah, so there's more than one way to do this. I think I prefer splitting the 95 in half rather than starting with this, because if you start with the 50%, then you have to think about, oh, how big is that little chunk, and then subtract off. And Yeah, a little bit more work than necessary. All right, beautiful. So there it is. So any issues or questions about those? All right, well, you can see the rest. So let me give you some instructions before you go. So first of all, and you can certainly stick around. We're going to be done a few minutes early. You can stick around. So first off, I have a couple of volleyball players who claim that they have to leave early for spring break for some reason. And they're going to be here at 7:15 to take their exam, not this exam. They're in differential equations. So they're going to be here at 7:15. I'll be here at 7:15. If you want to be here at 7:15, come join us. Otherwise, you can come at the regular time, and that's fine as well. So there's that. Secondly, if you have questions about the practice test that we did not answer, I'll be around tomorrow. It's a joy to come. If you come to my office, I'll even make you a latte if you want. I've got the equipment in my office. So come by and make me happy. And then finally, one of my colleagues who you probably have heard of the various budget cuts, one of my colleagues who is not going to be here next year said, "Oh, I want to have T-shirts." And I was like, "Oh, why?" And she's like, "Oh, we'll do it." So I had a bunch of T-shirts made up. You may have seen them, just to make my colleague happy. And so I bought a bunch of them, and it'd be nice to recoup some of my cost. But if you don't want one, that's fine. Just wanted to brought a few. I've got a bunch in the math office. It just has the names of the various faculty who are sadly not going to be here next year. So I paid $15 for them, but I'll take whatever you want. I've had people give me $5 or $10. So there's my Venmo. If you want one, you can have one, or stop by the math offices later with cash. I'm happy to take your cash as well. So that's that. Hope you have a great day, and we'll see you on Friday.